let's explore what a box and whisker plot is and how we can use it. So first off, let's say you went fishing one day and you caught 15 fish, measured all the fish. So you've got a 3-inch fish, a 5-inch fish, all the way up to a 39-inch fish. So I've put this data in order. You may not have caught them in order, but it's good you put the data in order. I just did that to save some time. So here's the data in order from least to greatest. And to make a box and whisker, you first find your lower extreme and your upper extreme. And so our lower extreme is a 3 and our upper extreme is a 39. So here's our lower and upper extreme, so 3 and 39. And these are called the whiskers. Now I usually find those first so that I can determine the scale to use. Well, I already got the scale up here. I went by 2s because I have 40 marks here, or 20 marks, excuse me. And so I could go by 2s and fit all my data on the number line. But the scale is important to get that set up first. So the first thing you do for a box and whisker is you measure out your whiskers. So since I'm going by 2s and this one is actually 0, we're going to put a mark here to represent the lower extreme and a mark at 39 to represent the upper extreme. Oops. Okay, and this is considered our whisker. And we'll draw a line connecting them. Next you find the median, which is also considered the second quarter of the data, the second quartile. You know, just like money, you can divide it into quarters. To do that, to find the median, you just count how many there are. There's 15 of them. So half of that would be 7.5. So we're going to count up 7. So you count up 7. 1, 2, 3, 4, 5, 6, 7. And that ends at 12. And count back 7. 1, 2, 3, 4, 5, 6, 7. And that ends at that 15. And so the number in between them is the median, which is 15. So we'll go ahead and graph that with a line. So that is our second quartile. A lot of times you'll see it represented Q subscript 2. Okay, now to find the lower quartile, we just want to find the lower quarter of our data. So I'll do that in a different color. And so you basically break the data in half. So we're going to find the median of this data right here. So there's 7 in that data, so we'll count up 3. 1, 2, 3. Count back 3. 1, 2, 3. And notice 8 falls in between those. So we'll graph 8. So that is Q1, our first quartile. Oops, that is supposed to be a Q, even though it's sloppy. So we've got 15 for Q2, 8 for Q1. Now to find the upper quartile, and to find it, you just find the median of the last half of your data. And so we have 7, so you count up 3, so 19, back 3, which is 25. So 20 is the upper quartile, which we often call Q3. Okay, and so I'll graph 20, and that's right there above the 20. And here's where the box comes in. So we're going to make a box out of what's called the interquartile range, the 8 and the 20. So we'll make a box here. And that just shows you in the scale where your half of your data lies. The middle half of your data lies between 8 and 20. And notice we're catching slightly smaller fish, a majority of them, rather than the extreme out there, that 39-incher. So we're catching more small ones than the big ones. And it works actually better if you can compare like maybe 2 people and the fish they caught for the day. So maybe somebody caught bigger fish. Box and whiskers always work, I think, better when you have multiple sets of data to work with and you want to compare. So I hope you like this, and I hope you now understand what a box and whisker plot is, and I hope you use it at some point in your life. Thanks for listening.